Hello everyone and welcome to my YouTube channel. My name is Subhashish Mishra and today's topic of discussion is on linear regression. Before we start, if you are new to my channel, please subscribe, like, share and also turn on the notification bell so that whenever any new video gets uploaded, you will be notified. Alright, let's get started. So before understanding linear regression, we need to understand what exactly is a regression. So regression is nothing but a relationship between two variables. For example, we have a variable called weight and another one variable called as height. So whenever we try to find out whether there is a relationship between weight and height, then the relationship that we will be able to draw, that is a regression relationship. So in terms of that, we can be able to say that regression analysis is a technique of understanding the relationship between independent and dependent variable. So in my example, we can take height as our dependent variable and weight as our independent variable. Based on the weight, we can be able to decide height, or based on the height, we can be able to decide the weight. Both of them we can take as one of them we will be taking as the independent, another one we will be taking as the dependent variable. So regression is an approach of predicting continuous variables. For example, in this case, I have taken the example of weight and height. So weight is a continuous variable and height is also a continuous variable. So whatever the relationship we will be getting, the relationship will be continuous relationship. So this is the important note to remember, that whenever we have any continuous variables available in terms of our output variable or the predictor, then in that case we will be able to say, okay, the relationship that we are going to draw or the model we are going to apply is a regression model. Now let's understand what is linear regression. So in the context of regression analysis, the first model we will be learning is linear regression. Linear regression is a linear combination of coefficients and independent variables combined with the intercept or error term to find out the predicted variable or output variable. What exactly is that about? So in my example that I was giving, weight and height. For example, somebody's weight is of 80 kgs and that person's height is of 160 cm. And we are being able to see that, okay, there is another one person whose weight is like 70 kgs and his height is, for example, 140 cm. So here we can be able to say, okay, if we compare the relationship between weight and height, then whatever the value of the weight we have, the height value is exactly twice of the weight value, irrespective of the measuring unit. So in this case, what we can be able to say, if weight is the y or the predictor variable and x is the independent variable, then we can be able to say the relationship between y and x is here y equal to 2x, because it is a twice of x. Okay, so here 2 is the coefficient and x is the weight variable. In linear regression, as its name suggests, we try to find out a linear relationship between independent variable and dependent variable. Like with increase in x, whether the y increases, with decrease in x, whether the y decreases, or vice versa. So in mathematical term, whenever we try to put in linear regression, then we know the famous linear regression equation is y equal to mx plus c. Here y is the output variable or the dependent variable, m is the coefficient for the x, and x is the independent variable, and c is the intercept or the error term we can be able to say over here. Now let's understand what are the types of linear regression available. So there are broadly two categories of linear regression which we will be using in our day-to-day life. Obviously there will be other linear regression categories like polynomial and any other categories as well, but these are the most important ones which we'll be using in our day-to-day basis of the machine learning journey. So the first one is simple linear regression, the second one is the multiple linear regression. Okay, in simple linear regression, we have only one independent variable present and based on which we try to predict the dependent variable. Like the way I have given an example of weight and height. Here weight is the only independent variable available based on which we try to find out the height of the person. So it comes under a category of simple linear regression. In multiple linear regression, we have more than one independent variables and based on which we try to predict the output variable or the dependent variable, that is the y. So if we take an example based on the number of years of experience of a person and based on the skill sets he has worked, if we try to find out that what is going to be the salary of the person, so that, and based on the education also, so these are there are three independent variables over here. One is the education, the second one is the skill set of the person, the third one is the number of years of experience, based on which if we want to decide what is going to be the salary of the person, so that salary of the person is dependent upon these three independent variables. So this is an example of multiple linear regression. Now let's dive in a little bit detail about simple linear regression. As I was saying earlier, in simple linear regression, we have only one independent variable and one dependent variable. So based on the independent variable and its coefficient, we try to find out the dependent variable. So here the equation is always simple, that is y equal to mx plus c. In an xy plane, we have all the data points jotted down in a straight line. And on top of that, if we try to uh, create a best fit line or produce a best fit line on top of it, then if that best fit line passes through the origin, then we don't have any error or intercept available over here, because intercept is the error. Whenever we have any best fit line which passes through the origin, that means that is a perfect fit line. Whenever we have any straight line that doesn't pass through the origin, that means it's not a perfect fit line. So whenever we have, so in this case, as the line passes through the origin, so we don't have the c, that is the intercept. So here, as the c is 0, so our equation will be y equal to x. So what, because here as per our understanding we are considering x equal to y, means if one in 1 unit increment in x is equal to 1 in unit increment in y, so here the coefficient will be 1, but that will not be the case for every time. So in this case we can be able to say that the relationship will be y equal to mx, m will be the coefficient. So here in our case it is 1, so we don't have to write down m as 1, so it will be y equal to x. So it can be 2x, it can be 3x based on the scenario. The second aspect of the simple linear regression is, however, where the straight line or the best fit line that we are creating, that doesn't pass through the origin. That means it has some sort of error. So here we can be able to say that the line passes through the 1 in y. So that means this 1 is going to be our intercept value. So here c equal to 1 or intercept equal to 1 and y equal to mx. So in this case, for us the equation will be y equal to mx plus c. Now let's understand about multiple linear regression. So in multiple linear regression, as we were already discussing before about the salary of the person, predicting a salary of the person based on the number of years and the skill set and the education. So here all of these three will be like x1, x2 and x3, and their corresponding coefficient will be m1, m2 and m3, based on which we will be try to find out the y variable, that is the salary component. So equation of multiple linear regression will be y equal to m1x1 plus m2x2 plus mixi plus c. C will be the intercept. So in multiple linear regression, we try to find out, as I was saying, we try to find out the relationship of individual independent variable with the output variable. And also when we create a model, then we take a look at the collective contribution of individual variables. Also once the multiple linear regression is been done, then also we take a look after the collective contribution of individual variables, like how well they are contributing to the output variable prediction. Some feature may be contributing in a positive direction, some feature may be contributing in a negative direction. We need to take a look after that. And also on top of that, we have to take a look after the individual relationship between the independent variables. Like let's say we have three independent variables over here, and we need to look after that how one independent variable is impacting another one independent variable. For example, we need to see that how the education of a person and the number of years of experience of a person is related to each other. So multicollinearity is what? Whenever we have two or more number of independent features which are highly correlated, means if a single unit of change in x1 is equal to, for example, 0.9 0.9% 90% increment in the x2, so that means x1 and x2 are almost similar to each other. So there is no point in terms of keeping x1 and x2 both the variables for the model creation. In that way we can be able to exclude one variable, either x1 or x2, and we can be able to train the model with either of them, like with x1 also, else with x2 also, but we will not be doing it with the both variables. Thus this is what the multicollinearity is roughly about, but we will be discussing in a greater detail what exactly is multicollinearity, how to address that, and if we don't address that, what is going to be the problem. So this is it for this video. We have learnt about the introduction of the linear regression, where we understood about the simple linear regression and multiple linear regression. In the upcoming video, we will be learning about what exactly is a multicollinearity, and also on top of that we will be seeing the assumptions of linear regression and how to implement in a practical aspect. Until then, stay tuned and enjoy machine learning.